So you're given all the sum and difference formulas. Now what we're going to do is we're going to find the exact value of the cosine of pi over 6 plus pi over 4. What I want to show you is why we could not find that answer, why it has to be in the summation formula. In order to add together pi over 6 and pi over 4, what do you have to have? Common denominator. What made a common denominator of 6 and 4? 12. So this would be this, excuse me, I'm going to write over here because we're not going to actually use the 12s. But this would be the exact same as, thank you. So this would be the same thing as if I said, hey, find the cosine at 5 pi over 12, and you'd say, that's not one that I have memorized. I'm going to have to type it in my calculator and find an approximation. But now we're going to find the exact. You can find the exact because of these formulas. So I'm not going to use the 12s. I am going to use the pi over 6 and the pi over 4. And then what I'm going to do is, this is cosine, it's addition. I'm going to plug it into this formula right here. So this will be the u value, and this will be the v value. So we'll do cosine at pi over 6 plus, nope, not plus, times cosine pi over 4. And then when we look at the formula, it says now I have a subtraction. Sine pi over 6, sine pi over 4. So I just used the formula that you were given. I believe in honors, you would have to like figure out how that formula was, what's the word? I can't think of the word right now, but you'd have to like figure out why that formula is true and like prove it and all that stuff. In CP level, we're going to say, here's formula, it works, let's do this, right? Okay. Now, that's a challenge if you'd like to figure out why it works. What is the cosine at pi over 6? No. Sine at pi over 6 is a half. What's cosine at pi over 6? Oh. Thank you. What's the cosine at pi over 4? You mean we still have to know this? Yeah. Okay, so then the sine at pi over 6, half, and then the sine at pi over 4. Okay, so partially what we're doing is we're plugging stuff in, but another thing that we're doing is we are reviewing rules for fractions. We are reviewing rules for radicals. All these things that you studied in Algebra 2 is now inside this one question. So we got to kind of review all those rules today as well. Order of operations. We multiply before we subtract. So I'm going to multiply these together. I have to multiply fractions. How do we multiply fractions? Straight across. When it's multiplication, you can do whatever you want. Can I multiply two radicals that aren't the same? Yeah. So radical 3 times radical 2 is radical 6 on top of 4. Minus radical 2 over 4. When we have fractions and we are subtracting fractions, what do we have to have? Do we have a common denominator? Because everything that we add or subtract in math has to be like terms. The like terms would be denominators. So I'm going to keep the same denominator and subtract my numerators. Next question. To do subtraction, we always have to have like terms. Is a radical 6 and a radical 2 like? No. Okay, so that's where we, this is where we're reviewing. They would have to have the exact same square root to be like. So this, I have a radical 6, subtract a radical 2, cannot combine them. This is actually the most simplified version of this answer. Now, how do we know that that really is the answer for cosine of pi over 6 plus pi over 4? Check it is an excellent thing to do. How? Let's all take out our calculator. Who did not come to class prepared? Everybody has their calculator? My jaw is dropping right now. Really? Oh, somebody's not talking. I should give you guys a hand. Yeah. Yeah. In a moment I will. Let's check it. You do it. Make sure you can type this in correctly in your calculator. And I'll go find my candy. Remember, if you have the TI 84 plus, hopefully you have the fractions. If you're not sure, hit alpha y equals. Oh, if you have the 84 plus CE, you definitely have it. But if you have the non-color ones, try alpha y equals. And if a little menu pops up, then you can use the fractions. Make your life a lot faster. Would yours work? Is that the thing, Julie, we still need to? Yeah. I have extra time, remind me. I need about 4 calculators in my first bill. 4. Here. Is there anybody allergic to peanuts in here? I don't know. I'm not asking for first. Anybody like going to die because there's peanuts in the room before I pass this out? Okay, most of this, this is not even chocolate, so we're probably good. Okay, did it check? Did anybody have trouble with their calculator? Did you do alpha y equals? Yeah, I had to change that. Oh, but it worked? Yeah. I can update your software, and there will be another way. But I'm not going to write this down. Yeah, but I don't know if I can update your software. I know I can update the color ones because I updated mine, so I'll show. Because my software is updated. Oh yeah, it's awesome too. I'll show you why you want to update your software real fast. But if I do Alpha X, it works like one of those things. But that's not the cool thing. When you update your software, it has. You can actually go. This is, you do not have this in your software. I mean, you have something like it, but it's not the same. Not as and I never showed it to you, but you could someday you could actually grab a piece of it. So you could type in, what the equations are, and then go over and type in the domain restrictions. Well, you have to have the updated software. So no, I don't know if it'll work on yours at all. I guarantee, unless you've gone on and updated your software. It's not updated. I had to go connect to the computer and update my software, which I can do for you guys in here once I remember how to do it. But that's what I did for that. What? Did I tell you the updated software? Oh, the Alpha X. Yeah. So she just bought her calculator because her other one broke. So she's the newest version. That's why hers has updated software. All right, can we move on? The next one, heads up, right now, you're going to need space. Okay? You heard me say it. You're going to need space. And a sucker. Alright, so this says find the exact value of the tangent of the angle, and the angle is going to be 15 degrees. So we are finding the tangent of 15 degrees. Is that one we have memorized? No, but we can make 15 degrees by a combination of the ones we do have memorized. Remember, we know, 30 degrees, we know 45 degrees, we know 60 degrees. Okay, I'm not going to change it into radians, but you can if you like that. I'm just going to leave it like degrees. But what would you want to do? 45 minus 30. You could do 45 minus 30. What also could we do? 60 minus 45. 60 minus 45. Okay, we do either. Should I do the hard one or the easy one? The easy one. Wouldn't you rather me show you the hard one?
No. Sure. Yeah.
Why not? The his nose. Or you can figure it out on your own later when you have the hard one in your homework. Yeah. Yeah. Okay. So we're going to do, what was the first one you said? You said 45 minus 30? Okay. We're going to do 45 minus 30. So I'm going to rewrite this as tangent, right small. 45 degrees minus 30 degrees. Then that's a tangent, that's a subtraction or a difference formula. So we're going to go up to the top and look at our formula and plug everything in where it goes. The difference tangent formula says, do tangent 45 degrees minus tangent 30 degrees, divide that answer by 1 plus tangent 45 degrees multiplied by tangent 30 degrees. Where did I get that formula?
Never mind, I know it.
Okay. So I got that formula, if you're not sure, from right here. Did it get around to everybody? Okay. So now we're going to plug in the numbers we know. Let's see, tangent 45, do we know the tangent of 45?
1.
And do we know the tangent of 30? Yep. And I do not want Linus to answer the bottom at all, because she has proved to me that she is a mathlete. Now I have 1, and I have plus, and then I'm going to multiply. What is the tangent of 45? I hope you all get that really fast. And I'm going to multiply that by what is the tangent of 30 degrees? Radical 33. We just did it on top. So. Okay, so now that looks yucky. Doesn't it? Well, this should be the answer. The only problem is I want your answer simplified, and this is not simplified. What's wrong? There's a fraction inside of the fraction and radical in the denominator. We got multiple issues here. Okay, I'm going to take care of fraction in the fraction first. You did this chapter 7 in Algebra 2 last year. It's like the worst chapter because you don't know your fraction rules. We do not want a fraction inside of a fraction, so we need to make this just one big old fraction. Only one fraction part. I will show you what I think is the easiest way of doing it. This is not the only way of doing it. Let me rewrite it so I don't have that 1 times in there because that's bothering me. Okay. So what I'm going to do is I'm going to take this and I'm going to multiply it by a value of 1. If I multiply by a value of 1, it does not change the value of this. I cannot change the value of this. This is an expression. This is the answer. So I cannot change what it's worth, but I can change what it looks like. So if I multiply by a value of 1, it's going to be the same thing on top and bottom. Now my value of 1 that I am choosing is 3 over 3. So I am multiplying by 1. But when I do this, look at the magic that happens. I'm going to have to distribute that 3. Look at this magic that happens. I'm going to have 3 times 1 minus, now right here I'm going to have this negative radical 3 over 3 and my office. I have this negative radical 3 over 3 and I'm going to multiply it by a 3, which is like multiplied by 3 over 1. And then these will cancel, so we just get a radical 3 here. So on the bottom, when I distribute, I will have 3 plus, and I'm going to do the same thing again, radical 3. So now we do not have a fraction inside of a fraction. We still have a radical in our denominator. So how do we rationalize? How do we get no radical in the denominator? Multiply by a value of 1. Can't change the value. It's got to be a value of 1. And then what were you kind of thinking? Radical 3 over 3? Radical 3 over radical 3? Okay, don't do it. Watch me do it. Don't do it. Watch me do it. Okay? If I multiply by square root of 3 over square root of 3, I have to distribute. I will end up with, on my bottom, 3 radical 3 plus 3. doing radical 3 over radical 3 does not work. I just moved the radical 3 to the other term. The problem is it's not just a square root down there. It's a square root that brought a friend. So we need the conjugate. We need the conjugate to help cancel it out. So I'm writing the word that I'm saying, so you know what I'm saying. Conjugate. And you should have learned about those in Algebra 2. The conjugate is when you take a binomial and you multiply by the exact same terms, except different sign in the middle. And we are multiplying by a value of 1, so it has to be the same thing on top and bottom. And I don't care about the top. It's the bottom that I want the conjugate for. It's the bottom that I want to change the sign for. Now, since I am multiplying a binomial, 2 terms, times another 2 terms, I'm going to put them in parentheses so I don't mess that up. Because how do we multiply a binomial times a binomial?
FOIL it.
Yeah, we're going to use the FOIL method. So now I'm going like all the way down around here because of the space. So on top I'll do my first, which is 9. My outer is -3 radical 3. My inner is -3 radical 3. And my last is negative times negative, positive, and then radical 3 is 3. The denominator, we have 9 minus 3 radical 3 plus 3 radical 3 minus 3. So what happens on the denominator when you multiply conjugates? The FOIL, in the FOIL method, the outer and inside always cancel. Do you have a question, Dave? Okay. You look like maybe you did. So my denominator now is 9 minus 3. Which is good, because now I don't have my radical. The numerator, combined like terms, I'll have a 12 minus 6 radical 3. So my next step is 12 minus 6 radical 3 over 6. So this is not our final answer, because we can factor something out of the top and cancel it with the bottom. You're only allowed to cancel when they're factors. So since we have binomial on top, we have to GCF factor it. What number can I factor out of 12 and 6? You do not factor out of the radical. Out of 12 and 6, we're going to factor out a 6. I'm left with 2 minus radical 3. On the bottom, I can also factor out a 6. So if you can factor it out, that's when you're allowed to cancel it. If it doesn't factor out and you cancel somehow, then you might be breaking some laws and killing some buddies. Happens often. So now I get 2 minus radical 3. That was a lot of work. That's like the one that might take you the most work. After doing all that, do I really want to just kind of guess and make sure I'm right? Or should we check it? Did you check it? Let's check it. Don't give away what I know people are going to do wrong. If they can figure it out. Oops. Oh, no. What did I do to be able to check this one the way I checked it? You see my calculator up there. What did I do? Yeah, I was typing in 15 degrees, so I had to make sure that I put my calculator into degree mode. If you don't want to keep switching your calculator around, then you'd have to know what 15 degrees is in radians, and then type that radian in. I don't know what it is. What is it? Is it over 12? Okay, so it looks like it's right. Yay! Okay, the next example. We shouldn't need as much work now for these. The next one is find the cosine at 11 pi over 12. So I'm going to write that here because that helps me know what I'm doing. Do we know this one by memory over 12? So what I'm going to do is I'm going to find either things that subtract or add together to give me 11 pi over 12. And then you think about the pi's that we actually know. We know things like pi. That's like 180 degrees. We know pi over 2. We know pi over 3. We know pi over 4. We know pi over 6. Those are like pi's that we know. Let's look at those pi's being over 12. Let's change their denominators so that they're over 12. So what would pi be? Okay. I didn't really leave myself space to write that in there. I'll just change color. Okay, so this would be like 12 pi over 12. What would pi over 2 be? Yeah, 6 pi over 12. 4 pi over 12. 3 pi over 12. 2 pi over 12. How can we make 11 pi over 12 either using addition or subtraction? So these can't be the only ones we know. Because we also know multiples. Like, we don't just know pi over 3. What do we also know? 2 pi over 3. So if you want like 4 pi over 12 and another 4 pi over 12, which makes 8 pi over 12, that's really 2 pi over 3. What?
2 pi 3 plus pi 4.
Oh, plus pi over 4. Yeah, if I do a 2 pi over 3, which is like 2 of these, plus the pi over 4, which is 3 more pi's, that's going to give me 11. 8 plus 3, 11, yeah. So we're going to be adding, we're going to take this, we're going to cosine 2 pi over 3 plus pi over 4. That is probably not the only way you could do it. But that's what we came up with first, so we're going with it. So now we use the cosine formula that is available to you on this sheet. And we do cosine at 2 pi over 3, cosine pi over 4, minus sine 2 pi over 3, sine pi over 4. So we have to know the cosine at 2 pi over 3. If you need to draw it, then draw it. 2 pi over 3, it's a negative, and it's a radical 3 over, no it's not. Yeah, it's negative half. Yeah.
Oh, yeah, it is.
The last mistake you're going to make the whole year, right? Nope. Oh, okay. All right, and then cosine of pi over 4, radical 2 over 2, minus, now we want the sine at 2 pi over 3. Is that going to be negative or positive? And then the sine at pi over 4 is radical 2 over 2 as well. Not us. So now again, let's review how do we subtract and how do we multiply fractions. Multiply straight across first. So we'll get negative radical 2 over 4 and then minus radical 6 over 4. And then to add fractions, common denominator. Negative radical 2 minus radical 6 over 4. And then can I actually subtract radical 2 and radical 6? Yeah. So then that would be as far as I could go. And then if you want to know if it's correct, you pull out your calculator and check it. We're moving on. It's right. Okay? Now I have to find the exact value for sine 75. This is going to be, you try and see if you caught on to what we've been doing. Okay? And then I'll go over it, but you try first. So I'll pause this recording. You try it. So that's kind of what my first step looks like. It's just, okay, well, it's going to be 30 plus 45. Then I go to use my formula from the top of the paper. Sine 30 degrees, cosine 45 degrees, plus cosine 30 degrees, sine 45 degrees. Filled it in from a formula, that's it. Then I need to know my sine at 30 degrees, half cosine, and then cosine at 30 degrees, radical 3 over 2, sine of 45 degrees, radical 2 over 2. So we get radical 2 over 4 plus radical 6 over 4, radical 2 plus radical 6 over 4. When you are ready to go on, flip your page over. If you have a question, please ask. Go ahead and read that next question. And we'll catch up to you. Probably in the text. I mean, I guess you could have that. Probably the same answer.
I mean, it I know.
All right, this next one says just to take this expression and write it as like one trigonometric ratio of an angle. So when I look at this, I have to figure out if this is sine, cosine, or tangent. How do you know it was sine? Formula. Yeah, the sine formula starts with sine. The cosine formula starts with cosine. And the tangent formula has tangents in it, so I think we already know what they are. Then you just have to figure out if it's plus or minus. You look at your formulas. The sine formula is minus when it's minus. The cosine formula is opposite. And then the tangent, the top one, is the same as you know what it normally is. Okay, but you have your formulas. You can figure that out. But I just like, as I do it over and over again, I try to make it easier on myself, and I think of patterns like that. Okay, so then we're just going to do sine of 60 degrees minus 45 degrees. So this would be sine of 15 degrees. Yes. Now, could you answer that? Is that one we know? Okay, so if it's not one we know, then we'd actually have to use this thing to answer it, but I'm not asking you to answer it right now. So the next one's going to be cosine. And because it's a minus, it's actually plus, so we do 45 plus 120. So cosine, 165 degrees. Then this one, tangent, 68 minus 115. So we get tangent for negative 47 degrees. Did you type it in your calculator? Was it the same as your 300 and whatever? Same. All right, so that's it. Next section is find the exact value of the trigonometric function given sine u is 3/5 and cosine v is negative 513, and u and v are in quadrant 2. A lot of information here. So we read it and we process it and we say, I have no idea what to do. No. What kind of tricks and tips have you learned throughout math classes when you are stuck and you're not quite sure where to start? Okay. Draw it. That would be 100% my advice. Would be let's draw it. It says both of them are in quadrant 2. If you want to draw one quadrant 2 and put them both in quadrant 2, that's fine. I'm going to draw 2 separate ones. That's just me. I'm going to draw 2 separate ones. I'm going to draw a picture for you. And I'm going to draw a picture for V. And in quadrant U, in U, sorry, the angle U is quadrant 2. Angle V is also in quadrant 2, so I've got my two pictures. And sine is y over r. So up here I'm going to put 3 and 5. And then right now, yeah, you inside of yourself right now, you're like, I gotta put the answer there. I gotta put the answer. What's the other side? What's the other side? I gotta put it down. I can't leave it like this, right? Is that what's happening? No, just for me. You don't want to put that answer there so bad?
I do.
Okay. What is it? Oh, you're so close. It's negative 4. Why?
Because it's a quadrant.
Because it's a quadrant 2. Okay, so then for B, we have cosine, which is x over r. So we'll have our 5 and our 13, but which one is negative? Why is 13 not negative? Hypotenuse is never negative. The radius is never negative. It's the direction of where we're graphing. That's why that one's negative 5. So now we just have to do the sine of u plus v. Do you know the angles? You could find them, but it's going to be a decimal, and we need to do an exact. So we're going to use this formula, which I'm just going to copy so you don't have to keep flipping over. The sine formula, does it start with sine or cosine?
Sine.
And it's sine u cosine b plus cosine u sine b. That's the formula. So since we don't know the angle, how do we find the sine of u? That's what was given to you. See it? Here's the sine of u. Where do you know that answer? 3/5. And the cosine of v was given to me. Negative 5/13. Plus the cosine of u. So that was not given. However, because we had to put that negative 4 in there so bad, we can find out what is the cosine of u. And then this one must not have been as bad because I skipped over it. What is the missing side in this one? 12. It's a triple. I gave you a triple. So then our sine at b would be 12/13. So we simplify. We're going to get negative 15 over 65 plus negative 48 over 65. We get negative 63 over 65. Do we reduce? If we can. Can we reduce? What are the factors of 65? 5 and 5 and. How do you know that so fast?
Just because you just did it.
Is that how we got 65?
That's not even how I'm doing.
Because we just multiplied them there? Yeah. So the factors of 65 are 5 and 13. And 1 and 65. What are the factors of 63? 9 and 7. So a 3 would also be a factor. The 21 would be a factor. That's not really helping because none of them are 5 or 13. So it does not reduce. So the next example is a U-try. Okay, I'm going to pause the video. You try this next example. It's the same as the one we just did, only it's subtraction and cosine. Okay. So I'm going to draw two pictures. I'm going to draw a picture for you, and I'm going to draw a picture for me. They're both in quadrant 3. You put them in the wrong quadrant, possibly going to get the wrong answer. So for you, I'm given the sine. So I'm giving the negative 24 is the y, 25 is the radius, and then that means my triple, negative 7, will be the x. It has to be negative, it's third quadrant. And then cosine for v is negative 4/5, and then that means that y is negative 3. Again, watch those negatives. We're going to do cosine of u minus b, so that's cosine u cosine b plus sine u sine b. Just Plug in the information. Cosine u is -4. No, other one. -7/25. Cosine b is -4/5. Sine u, -24/5. 25. And sine b. Positive 28/125 plus 72 over 125 is 100 over 125, which is 4/5. How'd you do?
Yep.
I did it. Did you do it well?
Like, I know it's I'm not going to, I was just still down.
Happened. The real learning is not really by watching me. You know, the real learning is you doing it. That's where the learning comes in. Or explaining it to a friend. Or to somebody you don't like. Explaining. All right, the last one says verify. When you see verify, that means we're doing the trig identities where you box in one side and only work on one side at a time. Look at these two sides. Which side should we box in and not touch? Good idea. So on the other side, I've got sine, and then there's a subtraction. So I'm going to go use my subtraction formula with the sine. It says to do, on the screen, it says to do sine 3 pi cosine, x minus cosine 3 pi sine x. Now we have to verify that that equals sine x. Does anybody have an idea of something I could do next? Because I can't do anything that sine x. I can't do stuff to both sides. I can only do stuff on this left side. What were you going to say? Well, what identities? Are they squared? So no. No, because we are not, this is not the thing where we do stuff to both sides. Because we're not solving it. We're just changing one side. So we will not be able to use Pythagorean identities. Julie.
How did 3 pi is 0?
How did you know that?
Because it's the same side as pi, because they're
Okay, so Julie said, hey, why don't we go find the sine of 3 pi? That's a number. It's already told, we already know the angle. Let's go find that angle of 3 pi. That's one I should know. It's the same as pi. It's easy as pi, isn't it? So that's the order pair -1, 0. So what is the sign at that point? 0. So I'm going to replace that with 0. Cosine x minus, ooh, should we do the same thing with cosine 3 pi while we're at it? Yeah. So what is cosine? Okay. So now, what's 0 times cosine x? And then if I subtract a -1 sine x, I'm adding the sine x. Do I do another step? Do I do another step? Yes, you show me, oh, 0 plus sine x is sine x. You show me that. Yes, I know that's true. I know you know that's true. Show it. And then, yay, we verified it's done. And we're done with that. Yay. Okay, so I kind of said this earlier, but I have a worksheet for you today. Then I have a worksheet for you for Friday, but I'm giving it to you today. And I have a test review for you for Monday, but I'm giving it to you today. The first one I gave you. I'm going to give it to you in order. The one that says like worksheet 1. I think it's a worksheet 1. So I'm going to give it to you in order so you know exactly what to do. But that way you can work ahead. I already had some people say, hey, I'm going to be on a college visit this day. I'm going to miss part of the rest of the week. You already have everything you need before your test Tuesday. If you know you aren't going to be here Tuesday, you may want to talk to me about how we can maybe take it early. or you just wait till after break, but just heads up, after break, after break, I'm only gonna be here for 2 days. And probably don't want to grade your paper Tuesday night before I go in. I have to be there at 5:15 in the morning, Wednesday morning.
I mean, at least you don't have to ask for people.
Right. Least of my concerns, but yeah. But I probably want to just spend some time with my family that night instead of grading your test that you could take it early. What?
No pressure.
You're over it.